Testing. Aryan and Mike, can you hear me?
Yeah.
All right, good, Aryan. Mike.
Yeah.
Okay, good. I can see your video, Aryan. Please set it up like last Sunday. Same thing with you, Mike. And Aryan, no need to mute. All right. Okay, can see it quite clearly. Now for Aryan, please set it to a landscape mode. The zoom is still in portrait mode. Okay, hello Noah, can you hear me now?
Yeah.
Okay, good. All right, so just waiting for, okay, good. Yeah, good, good. Yeah, good. Aryan, I can now see your writing very, very clearly. Okay, good. Right. And Ryotaro is also here. Okay, Aryan, the video did turn off, right? Okay. Not sure why. Just now was great. So for Noah and Mike, set it up, but please unmute, yeah, so that we can have a better communication. Right. Yeah, again, the zoom is great, Aryan, but it is back to portrait mode. So I'm not sure why. Sometimes handphone does this, so you have to landscape it again. Right. Okay, not yet. There's still landscape. There's still landscape. Right. Like, I mean, tilt your phone. You need to tilt your phone. Tilt your phone for a while and let it enter landscape mode. Like, yeah. Yeah, I mean, hold it in the landscape mode. Just now you successfully do it. So hold it in landscape mode. Right. Aryan, I mean, like you can see me. I mean, you must hold your handphone like this for a while. Then the zoom will set it to landscape unless you lock it. So you need to do this for a while. See. So now it is at landscape mode. Now it is correct. Excellent. Good. 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 Keep capacity. Okay. So, all right. So very quickly, update me what's going on. Yeah. So Aryan, tell me what's happening in school.
Right now in school, not a lot. We're just going through homework.
Right.
But I want to do this thermal property
Yes.
assignment.
Why is that? Oh, because it's an assignment.
Yeah.
All right, understand.
That's a good practice for me.
Okay. Okay, sure. Anything about chemistry and math then?
Not yet.
Not yet. Okay, understood. Okay, sure thing. All right, so I'll get updates from other people first. Huh? So Noah, tell me what's your update?
Doing linear law.
Sorry, Noah, you're saying? Sorry.
I'm doing linear law.
You're doing linear law. All right,
Yeah.
and looks like you're practicing the what in front of me is a linear law also, huh?
Yeah.
Okay, sure thing. Anything else? Any other updates?
No more.
All right, understood. Okay, so you kindly do that. I'll get updates from other people and then we can start. All right. So, Mike, is there anything wrong? I cannot see anything yet. And Noah is gone.
Yeah, I'm still setting.
All right. Okay. Okay. Ryotaro, maybe give me a very quick update first. You can give me more later. Yeah.
Most of the subjects are starting new chapters.
Give me the name. Give me the names.
chemistry is metals, physics is general wave property,
Okay.
AMF is doing the trigonometry. Like we finished the graphs today.
Finish the graph. Okay, okay. Right. Then still known. What's the next one? Like maybe R formula. Maybe that's what you're doing.
I don't think we reached there yet.
I see. Understood. Okay. Okay, understand. So what should we be studying today? Is it physics?
Yeah.
All right. Did you have time to practice the papers?
I only went through like one whole paper. Like I did the sum of what you told me. Like I see first, then I do again.
Correct.
Like,
No
yeah.
problem. There's no problem
Yeah.
there. Right.
But yeah, I have a lot of questions because I don't understand.
Good. I think that's where we can start for today. Okay, good. Okay, lastly, Mike, give me your updates.
For school,
Yeah,
physics, we start learning wavelength
right. Okay,
and I don't know, the frequency and all that.
understood.
Hertz.
All right, understood.
And then EMF, not much. AMF, we are like literally just barely starting on differentiation.
Differentiate. Okay, good. Differentiation. Right. So yeah, you should find it not very confusing, right? Chemistry.
Chemistry, I think right now it's endothermic, exothermic.
That's supposed to be a new chapter.
Yeah.
Okay, understood. Okay, Mike, what do we have in front of us here? Still polynomial.
It's the same AMF, but like that's just the front. I still want to do a trig.
Okay, sure. All right. So we'll go quickly the first few questions first, okay, so that we can stabilize. So Aryan, what is it that you want to ask? Don't forget, everybody, sorry, prepare your Jamboard, share with me. If I need to write for you something, you will be done through the Jamboard, right? So don't forget about that. Right. But you don't have to write anything on the Jamboard. It's just me. Yeah? So Aryan, what's your question here?
Oh, I have no question.
Oh, sorry, I cannot hear you.
Oh, I have no question.
Oh, yes. Okay, you're still doing it. All right, understood. All right. Then Noah, what is your question?
This one.
Okay, show me. All right. Okay, point properly. Which one? All right. Okay, good. I can see very clearly. What is it?
How do I make it y equals mx plus c?
Sorry, what do you make it? What? Sorry.
Like y equals mx plus.
The good news is you did the logarithm correctly. That's what you're supposed to do. You may or may not understand it. And you are already at y mx plus c. So we're going to differentiate that by making as big Y, big M, big X, and big C. Yeah? Okay. Now, the big Y is log small y. Please write big Y below log small y. That's the big Y, which you already have it below, right? And then equals to big M is B. Again, write that down, please.
Okay.
Below B, which I believe you already did below, right? And then the big X is log small x, and then the C is log A. You don't have to cancel anything, but basically the worksheet is guiding you. What is your question exactly?
Is it supposed to be done like this?
I can only see, maybe I see the below one. Yeah, it looks great to me. It looks great.
How come I have to keep the log and all that?
I'm sorry?
How come leave the log y, log x, log a?
Okay, I think there's a problem with the speaker. Okay, let me use a headset. Wait, Please wait. Oh, my mistake. Wait. Noah, could you please speak again?
So we don't have to get rid of the lock of the
You don't have to get rid of the what? Sorry.
lock.
No, in fact, it is critical that it has lock.
Oh,
Big Y is not small y. Big X is not small x. Usually, big Y contains small y. Big X contains small x. Usually. So they are not small x equals to big X. If that's true, then why bother lah? Why bother with all this process? I'm guessing that you may not understand why do all these things first lah. Am I correct?
the teacher just say y equals mx plus b.
It will be very apparent maybe soon, like very, very soon, why you do all this weird thing lah, yeah? Okay?
Okay.
Okay, right, promise that. Right. So, Ryotaro, what's your question?
I'm still looking at my last year paper because I want to pick some. No, because I have too many, so I don't think I can do everything. So I just pick the one I don't really understand.
Do you have some ready, or you want to wait a bit?
I'll wait a bit.
Okay, then Mike first. Mike, what is your question?
My question is question 3.
Question 3. All right. Okay. So what about question 3? Could you zoom in a bit, please? Just a bit more. It's just a little bit blurry. Okay, thank you. So what's your question actually?
Do not know how to do it.
Okay, let me read very carefully then. Yeah. Right. So you're saying that you cannot sketch, or is it something else?
Don't understand. I mean, like, I know what a cosine and sine graph there, but like,
how do you sketch? Right. Okay. All right. So it goes like this. I turn off my video so that to make it better. Definitely your video improves. Okay. Good. Right. Okay. Your Jamboard, please. I will draw something on Jamboard. Pay attention. Have you shared your Jamboard with me, Mike?
Yeah.
All right. Okay. I'm gonna access your Jamboard. Mike, why is your video off? Sorry.
Oh, because
for some reason, yeah, your video is off. Sorry.
Every time I leave, like, or minimize Zoom, it's off.
Can you do Jamboard on your laptop then? It's probably easier that way. Much easier, yeah.
On my laptop.
Yeah, on your Chromebook, I believe.
My Chromebook.
Yeah, should be able to access Jamboard very easily.
But it's a different email, so.
Why? Sorry, why?
It's a different email.
It's a what? Sorry.
Different email.
Different email. Your Chromebook cannot add new accounts, new Gmail.
Oh, it can. I think can. Wait, hold on.
Can. Please try. It will make your life much easier. Yeah. I'll go to Ryotaro first. Ryotaro, what's your question?
Is this drawing?
You gotta stop moving. You gotta stop moving. I cannot read it.
Okay. Yeah. Okay.
Yeah, I gotta stop moving. It's still moving. What's going on here?
No, because the question is above.
Right. And we still have the zoom. We still have the kindly zoom in lah. I think it's very blurry. Kindly zoom in. Sorry, yeah. Kindly zoom in. It's very blurry. Okay, thank you. Show me the picture again. Thank you. That solves some of the problem. Show me the picture. Okay, thank you. I'm gonna take a picture. I'm gonna stop. Okay, I'm gonna go to your Jamboard. Yeah.
Yeah.
It's loading for a while. Okay, Mike, could you wait? Could you do something else? I'll get to you immediately. Yeah.
No, I'm done with it already. Oh, but you want me to do something else?
Something else. Yeah, don't wait for me. Waiting for me is a waste of time, and this is your prime time. Do something else. I'll definitely get back to you on question 3. Yeah, definitely. Yeah.
Okay.
Okay. Show me your. Okay. Yeah, you show me your working, Ryotaro. Very good. Okay. Yeah. So Ryotaro, you want to ask me how to draw this diagram? Am I correct?
Yeah.
the discussion may be long looking at how you do it. It may be a very long one. Is it okay?
Yeah, okay.
Okay, so what you draw is something like this. I believe you're drawing the 100 Newton like that, right? With a proper scale. But I cannot even see the scale. The scale, I believe, like you say, 6 centimeter or 100 Newton, something like that. I think that's your starting scale. Am I correct? It's very weird. Yeah, it's extremely weird because, I'm not sure why you want to do 6 centimeter, but there is nothing wrong with that though. There's nothing wrong. Huh? So I'm going to follow that. So let's assume that that's your 600. First thing I noticed that you don't even draw the arrow. That does bother me a bit, right? The arrow, I believe, is very important, not just for presentation, right? Okay, then you draw this one also 6 centimeter. So instead of doing that, I'm going to write 6 centimeter here, which is 100 Newton. So that part seems to be correct. I don't think your teacher is concerned with that, but the arrow is already a starting point. The 120, I believe, is also not a problem at all. So all these are correct. Beside the arrow, and one more thing. What is your question exactly?
I completely forgot what to do after this.
If you try to memorize, that will be bad. That will be very bad. So I believe you're drawing this point, right? Right? You're drawing this point. So the 100 Newton stuff is actually just following the drawing. Clear? Correct? Just following.
Yeah. Okay.
Right? So what you did actually, you did not do it wrongly. I noticed that here in the middle, you have this line, and I noticed that there is this arrow. Is that correct? I do see kind of something like that. Or is that just me imagining it, the arrow?
There is an arrow by erase because I didn't know what to do.
Right. I'll do it in a clearer manner. You notice that everything is not moving. They call it a fancy name, equilibrium. They are just not moving, correct?
Oh.
If they are not moving, up equals down, left equals right. All the up forces equals all the down forces. All the left forces equals all the right forces. If that is not true, something will be moving. Because it is not moving, both things are true. Up equals to down, left equals to right. Okay so far?
So up as in the 100 Newton up equals 100 Newton down. Is that what
100 Newton is not up and 100 Newton is not down. Let me show you what it means. What is true is the up portion. The up portion is that one. And this is the down portion. There is an up portion and there's a down portion. It is not the whole thing. As you will notice, this thing is shorter than that. So the up portion of 100 Newton is shorter than 100 Newton. Equally, the down portion. However, the up and the down portion are definitely the same. Thus, equilibrium. So far, so good?
Yeah.
Now, the left and right portion, which is what you need. You have the right portion here, and you also have the right portion here. Both from 100 Newton. You have two right portions, which is shorter than 100 Newton. So far, so good?
Yeah.
So the left portion needs to balance the right portion, right? The left portion, I'm going to draw to the left like it's easier. So it will be 1 and 2. Then they will be balanced. Take that in first. Please understand that first. Okay?
Wait, but why? What is that black line? I don't know.
That's just a guideline. That's a guideline. The back line is a guideline. It's a horizontal guideline. Cutting in the middle.
Okay.
Right.
Then
it's a guideline.
The two arrows. Wait, why? So this blue arrow. I mean, these two blue arrows is supposed to be what? What is this?
Be equal to the two green arrows. Left equals to right. You stop.
Oh, but then why is it not like one up, one on top of the black line, one below the black line? Why is it both in the straight line?
I draw one on top, one below for illustration purposes. They are exactly on the black line.
Oh.
Understand?
Okay.
They are exactly on the black line. The black line is the guideline in this case. Okay?
Yeah.
Now, the details. what you're supposed to draw is how long. The length is what they are chasing after, is the length, right? So the blue line, just to be clear, using simple EMATH trigonometry. Yeah, this is 60 degree, this is 60 degree, can?
No.
So this thing is 100 Newton or 6 centimeter lah, right? Times sine 60. Okay. Now this two short one will be 100 Newton cosine 60 degree. That's your EMATH trigonometry. So therefore times 2 lah, because you have 2. So far so good?
100 Newton times 100 Newton is the
oh dear, the thing is very long.
the red arrow. Oh,
yeah, 100 Newton. 100 Newton has this portion and this portion. You're making it into horizontal and vertical. You're making it into a triangle. It's a 90-degree triangle. The 90-degree triangle keeps showing everywhere, from AMATH to EMATH to physics, right? It keeps showing everywhere.
Yeah.
Right. So this is the base of the triangle, which is 100 cosine 60, and then times 2 because that's 2 lah.
100 cosine 60.
Oh
yeah.
Yes. 100 sine 60, 100 cosine 60. Whether you know how to do it or not, you accept that first lah, to be correct.
Okay.
That's the trick part. That's a trigonometry part of this thing. Now, if this is true, then it's very clear how long this is lah. This guy is also 100 Newton or 6 centimeter. Cosine 60 also low, times 2 also low, but to the left lah. And that is what they're looking for. That's what the major thing missing from your drawing. That thing. That's it.
Okay.
And that is the force applied. That is determine the force applied by Archer. That thing lah. Right?
100 Newton cosine 60 times 2. That's the answer.
That is if you're using this drawing method. Your teacher will likely use another drawing method. I'm sorry to confuse you. I told you that this will be a long thing, yeah? So like that, okay. 100 Newton, right? 100 Newton, right? This is your 60 low. That's your guideline, then 60. And then he will attach the below one, strangely speaking, here. There. He will attach it there. That's the below one. But he will attach it here. Okay? And then he will expect you to say this is your force applied. This method, which is shorter admittedly than that one, in a few seconds, this length will be exactly equivalent to this length. Exactly.
Oh, I saw this one before.
Yeah, so there's the top method and then there's the bottom method. They are both drawing methods. Okay, you think about it first, right? So Mike, I can get back to you, Mike. So again, on Jamboard, yeah. All of you are definitely asking the long questions. I suppose that's good. You're supposed to sketch this and you're supposed to sketch that, right? Correct, Mike? Now, on your paper, Mike, sketch cosine x. Sketch cosine x for me, please. I need to see a good sketch of cosine x. In the meantime, just curious, Aryan, do you have another question so far?
Yeah, this question.
It's very blurry, so you need to focus for me, yeah? Focus for me, please. As in zoom in, sorry, zoom in, as in zoom in. I cannot read it properly, right? Zoom in for me. Can you actually zoom in? Like you pitch? Yeah. What's the question exactly? It's a nice drawing, Mike. Yeah, don't know why you cancel it, but it's a nice drawing. Number D, is it?
Yeah.
Right. So number D, I need to see the question. I cannot do this. I cannot read just yeah. So I'm gonna read very quickly. Yeah. Okay. Yeah. Okay. Thank you very much. Yes. Okay. Please move on to the next page. Yeah. Okay. No. Okay. Thank you. Right. So it depends on this. Okay. I'll get back to Mike first. The explanation is a little bit long, so please wait for a while, Arena. I'll get back to Mike first. So Mike, what you draw is nice. You draw something like this. You draw better than me. Correct, Mike?
I guess. Okay.
Normally, this will be 1 and -1, just to point out. Normally, correct?
Yeah.
I think that's the missing thing in your drawing, but don't put 1 and -1. Don't, because we're gonna deal with this guy and this guy. So we're going to deal with this 2 and this 1, which confuses you, correct?
Yeah.
Now, this is now 2 and minus 2. See, I just dealt with 2 cosine x.
Huh.
Why? Because
Oh,
cosine x goes from 1 to minus 1, right? So 2 cosine x goes from 2 to minus 2. Done, lo? Make sense?
okay.
But wait, don't. Now I'm going to deal with 1 very easily. Look, I'm going to deal with 1.
So
Last
does
one,
the
right?
top become the top become 3
3,
and then
1
minus
and
1?
minus 1.
Oh,
Not 3 and minus 3. You are wrong, 3 and minus 1. And then the middle one becomes 1. Now, there's one more thing that you have to do. You have to, I really mean is that you have to make this into dotted lines because it is no longer an x-axis. So please use your eraser, please. And then you have to now actually draw the correct x-axis, which is 0. Notice that we do this at the end, not at the start. Your start is fine. Make the middle line dotted line, please. Do not erase it. You need it. Make the middle dotted line and then draw the proper x-axis. Please do that.
okay.
Right. Okay.
I use pen to draw it, so.
Okay. Just pretend there's a dotted line and then draw the proper x-axis lah. You need to draw the proper axis at the proper position of 0. Where is 0 lah? You need to find the 0.
Can I just put it like
exactly in the middle of 1 and minus 1? Is very important. It's an accurate drawing. See?
oh,
If you
so
put it there, then you will be wrong. You will be wrong. It's very noticeable that you're wrong. Understand? Right. So for you, Aryan, I can answer a bit. So do you understand that your calculation will be a bit not according to the real thing lah? Your calculation not at C, your C is fine. Your calculation on B, you go to B. You go to B. You go to B, yeah? Right. Right. See, calculate the thermal energy released by the... Wait. Oh, I made a mistake. Sorry. I made a mistake. No, I made a mistake. Sorry, yeah. Let me take a picture. Sorry. I made a mistake. I thought it's something else. Sorry, Aaron. Let me take a picture first. I'll go to your Jamboard. Yeah. So, Mike, you are done with 2 cosine x plus 1. Understand?
Yep.
Right. Now, you want to draw sine x here. Now, since you are starting, do not draw immediately, but please draw it separately first. Please draw it separately as a practice. In a different place, just on the left, or on the right. Draw sine x for me, please.
Sine x.
Yeah, separately lah. So in a separate place lah. Please do that.
Oh, okay.
Okay, Aryan, I don't have your Jamboard. Can you give me a Jamboard?
The same. Oh yeah.
Yeah, I don't have a Jam. I don't have a Jam. Noah, just checking. Do you have a question? You're muted, Noah. Yeah?
I have a question.
Right. What is your question?
Yes.
Okay, zoom in a bit. Sorry, it's very blurry. Okay, thank you. What's your question? Oh, you don't know what to do, lah, right?
Yeah.
Okay, I'll make a suggestion first. Times everything door x and y. Times xy. Door times xy. See what happened. Now, Mike, excellent drawing. Now, Mike, using that new drawing as a guideline, you want to transplant that into your previous drawing. Transplant sine x into the previous drawing. Do you understand? Do it accurately. Do it accurately. That's the last step, and then you'll be fine. Ryotaro, are you stuck somehow? You actually even in exam you can use pencil. Actually, that's the weird thing. You can use pencil, right? So, Ryotaro, what's going on? Are you stuck somewhere?
I was looking at my notes from last time. Then I saw you must know the length of the f. Then you divide by something for this method.
I'm not sure what you're saying here. You know the length by drawing, right? That's how you know the length. You don't know the length previously lah, by right lah.
Yeah.
Right. Let me answer Aryan's question. Sorry, let me answer Aryan first. Yeah. Yeah.
I can't see the picture.
Sorry, Aryan?
I can't see the picture.
You can't see the, same problem, is it?
Yeah.
Hey, now you can. I believe now you can. No, cannot.
No.
That's so weird. You can move the picture, but you cannot see it. That's so weird. The picture is just, currently the picture is just your page. Just your working, nothing special. So just look at your working. Okay, I'm just putting it for my reading. So if I'm not mistaken, the D question is whether it will be higher or lower, right?
Yeah.
Okay. Let me think, yeah. Yeah. Okay, I'm gonna make a guess. Yeah, I'm gonna make a guess based on the question. Yeah, Aryan. Yeah? So even though the container is well insulated against heat loss, right? That's a good thing. But there will be still some heat loss from the top part, because obviously the top part is open. Right? Something like that. Can? Now, when they stir the water, and because the top part is open, some water will evaporate in some sense, and it will also hit the air on top using, and because of convection, you will still lose some heat over there, although not a lot. Make sense?
Yeah.
So the loss of heat is something like this. So the thermal energy released by the hot water going from 65 to 45. Let me put it another way. Yeah, how do I put it this? But that's, you cannot say that immediately. Alright, let me think about this. Let me think about this very clearly. What I should say. Right. Okay. Let me think about it for a while. Okay. Let me think about it. Right. Okay. So, Mike, what's your problem?
I'm just like making sure with pencil.
I mean,
it's off screen. No, I'm not like drawing it on this piece of paper. Just like,
oh, right. You're doing it elsewhere first.
Yeah.
Okay, and then please do it on that piece of paper or show your combined drawing. That's what you need. Right?
Yeah.
Okay. So Noah, what's going on? What's going on? Aryan, please do something else. Okay, don't wait for me. Yeah, please do something else. Right. Don't wait for me.
Make the base xy or
look, just Doldor x, just Doldor times xy. The way you do it is complicated. When you times xy, the 1 over x simply becomes y, right? And the 1 over y simply becomes x, isn't it? Correct, Anna? Correct, Anna?
yeah.
All right, so please do that, right? You can do what you do, but it complicates things a lot. And I'm just asking you to, look. I'm asking you to Doldor times xy. Actually, you did not do that. Doldor times xy. Doldor times xy. Write down Doldor times xy. Write down, please. Write down.
Yeah, I got it. Should be done.
Looks about correct to me. Yeah, it looks about correct to me. Looks about correct to me. Is it confusing, Mike?
Sort of.
Yeah, but that's your first time, right? So Doldor x times xy, please. Oh, goodness. Right. So sorry, stop there. No. Look. 1 over x times xy. What is it? 1 over x times xy. Yeah, times xy. What is it?
X over x.
No, I don't like your AMAT student and you complicate things they're supposed to be simple. No, I don't like it. I don't like it. It's not good. It's not good. Huh? It's not good. Okay, I'm gonna go to your Jamboard. not good at all. Okay, Ken?
Yeah.
1 over x times xy equals to y low.
Oh yeah. Okay.
Why so complicated? Do you understand? Why so complicated? Oh no, this is a totally no. You don't even have to do this. You don't even have to do this. I'm so sorry. There's something else at play here. You don't even have to do this. Watch it. Watch it. This will be very confusing. This will be very confusing. So far, so good, Ken? I'm just rearranging. Noah, is it good, Jamboard?
Yeah.
Okay. Something like that. As weird as it is, this is the answer.
Okay.
It will be very apparent when you start drawing things. Currently, you are not drawing things. It becomes very weird, I must admit. Okay. Okay. So, Ryotaro, what's your next question?
Why -1?
Follow first. Follow first. The M is -1. The M is -1. Okay. The M is -1.
Okay.
At this stage, unfortunately, you have to follow first. When the drawing comes, it becomes sensible. Ryotaro, what's your question?
Oh, I still don't understand. So once you know the length of f, then are you supposed to divide by 100?
Tell me your scale one more time. Do you still stick to 100 Newton, 6 centimeter? Is that what you're sticking with?
Yeah.
Okay.
Wait, am I supposed to? Yeah, okay.
No, that's up to you. The scale is up to you. The scale is up to you. So instead of writing 100, I will now write 6 centimeter. Fair enough? Right? So according to the first method, 6 centimeter, and then the green arrow. The green arrow is 6 centimeter times cosine 60. Press the calculator, please. Quickly. 6 centimeter cosine 60. 3.
3.
3 centimeter times 2 is obviously 6 centimeter, right? This is a coincidence, I just want to say. So this line is supposed to be 6 centimeter, Jano. You're supposed to draw 6 centimeter there. Finish. Okay.
Well, wait, but the cosine 60 come from where?
Let's do the second method first so that it makes more sense, right? So this is 6 centimeter, right? 6 centimeter, and this is 60, right? Okay.
But 6 centimeter, you need to do the cosine 60 times 2, right?
No, the 6 centimeter comes from 100 Newton, your scale. 6 centimeter, 100 Newton.
Oh, yeah.
Okay. Right? Okay. And then this is 60 degree because that's half here. This is 60, right? That's the first thing you draw. Okay.
Yeah.
This is also 6 centimeter, and this is also 60 degree also. Because this is 60 and this is 60. Because of that, when you draw this, you will draw this just automatically connecting this. That's the beauty. Connecting this, and then you measure using a ruler, you will discover that this is also 6 centimeter. Therefore, the 6 centimeter concludes is also 100 Newton. The second method draws the F first and then use a ruler, discover that it is 6 centimeter, then conclude that it's 100 Newton. That's how you do it. Maybe the second method is easier to understand. I think the first method confuses you a lot. I feel. So never mind for now.
Yeah.
Okay. Do you have another question on this?
Yeah. This one, no. Because the exam only give one of those.
Okay. All right. I go to Mike and Aryan, and then I'll go back to right. So Mike, are you doing something else? Because I'm not seeing any other question.
So you asked me to tutor.
I asked you to what, sorry?
You asked me the DD Doldor.
No, that was Noah. That was Noah. No.
Oh,
No.
then what do you ask me to do?
Don't wait for me, you do your own question.
Oh,
I'm just asking, what is the next question you're doing? That's what I'm asking.
no, I still need to state the number of solutions in this.
Oh, the
Which
number of
I
solutions means
don't know
something.
what it means.
Right. So what it means is very important. What it means is that when 2 cosine x plus 1 equals to sine x, meaning when they are equal to each other. Does that make sense first?
When 2 cosine x plus 1 is equal to sine x.
Yeah, that's what the solution of the two graph mean, is when they intersect, basically. When they intersect, right? Now,
when
from
they
the drawing, how many times?
There's two intersections.
Yep, and because you draw nicely, the two should be correct. Look. That's it. Look. That's why they say state, because you can just see it from your drawing.
So wait, when they say state, do I say like 90 degrees or what?
No. They just state how many solutions to look at. Like not.
Oh yeah, state the number of solutions. Yeah, okay.
It's not the position there's not even the position that they want, so to speak.
Okay.
Next question. Make sense?
Yeah.
Now, this happens a lot, yeah. So I really want you to understand the skill, and hopefully you can practice it again. Understand?
Yeah.
Okay. Right. So Noah, any questions so far? Excellent. That's the 1 over x. Yeah. Okay, I understand. So you write down this, big Y equals to big M, big X plus big C. You write it down first quickly. Now the question actually tells you a lot, Noah. The question tells you that big Y is 1 over small y. So you write that down. On the left hand side, 1 over small y is equal to, right? Now the big M, let's wait for a while. The big X, the question also tells you the big X is small x squared. So you also write it down below big X. Now, the graph actually tells you the big M and the big C. It's just hidden. How come I'm so sure? Because, first of all, they give you 2 points. Those 2 points can give you the gradient. Make sense? Noah, make sense or not? Make sense or not?
Yeah.
You should find the M separately using the 2 points, and believe it or not, you can also find the big C from those 2 points after you find the M usually. Okay, if you cannot, then we'll talk about it, but go and find the big M first. Go and find the big M first using the 2 points. Make sense? It's just a normal EMATH big M. Okay? Okay, give it a try. Aryan, would you have the next question? I still owe you one.
I just wanted to ask, do you have an explanation for the question I asked you last lesson?
I do have. Okay.
Yeah.
However, I would like to ask for your patience. I think we should talk about it like after the 1 hour. I think it's easier that way. I need to show you the video. You need to do something. Then everything makes more sense. Okay?
Yeah.
So give me a bit more time later. Right? Is there any new question?
Not yet.
Okay. So I owe you 2 questions. I owe you 2 questions. Ryotaro, what is your next question?
It's on page 2.
Oh, right. Good. Thank you for putting it there.
God.
Yes, Mike.
What does it mean when this happens? Because 2 cosine x over 2. Like, what do I do with the x over 2? Oh,
goodness me. Right. Do what I asked you to do, like the 2 cosine x plus 1, then I'll tell you the differences. Okay? You do that first. Right? I'll tell you the half later. Don't worry. Yeah? Right. So Ryotaro, what is your question exactly? It looks like this is a long one. So what is your question exactly? Everything?
Yeah, I guess so. From B to D.
Is this the right thing to ask today? Is it the right thing when you're trying to do the exam? Is it the right thing to do? Anyway, you plot the graph correctly, so that's great, right? I
can pick another question.
I'll try the shortest. I'll try the shortest thing. If you have to go through a thorough explanation, this is not the topic for you right now. Do you understand? It's not. You cannot do new things 2 days before exam. Okay, you must accept that. So I do a very short explanation. If it works, it works. If it doesn't, we have to go to the easier topics for you, not the harder one, which requires thorough explanation. Not at this point. Make sense?
Yeah.
If you have to go through one thorough explanation, then you go to another thorough explanation. Most of the time, nothing sticks because we are rushing things through. Make sense? Yeah. Okay, so let's try. So I'll go something like this. The idea of ideal gas. This is ideal gas, correct? That's the chapter. That makes sense? Do you understand that this is ideal gas?
No.
The particle. Sorry, never mind. I mentioned the wrong phrase. Kinetic. Particle model of matter.
Oh yeah.
Right, the particle thing. So the particle model of matter teaches us one thing: to see things from the gas perspective. Let me explain why. So our perspective is there's volume, there's pressure, and there's temperature. No? That's our perspective. Make sense?
Oh.
What about the gases perspective? What you must understand is that for the gas, temperature don't exist. It does not exist at all. The gas are collection of particles flying around. That part you can accept, right? It's a particle flying around. If you can have a very small thermometer, which you cannot, and you measure the molecule, you do not get any temperature. In a sense, particles don't have temperature. That's the thing you must first accept. What they have is, first of all, speed. So temperature in the gas point of view is their speed. If the gas's speed is higher, his temperature to us is higher. Gas's point of view, our point of view. Whether that makes sense for you or not, I suppose it's a matter of can you identify with the gas point of view. That's something not very easy to do, but that's what it means. Temperature is speed to them. They don't have temperature at all. So far, so good?
Okay, yeah.
Pressure is also what we feel. We can actually feel pressure. They don't. This is not a balloon. You cannot pinch the particle and then expect them to feel like a balloon. They are very solid thing to us, so to speak. So what is their point of view? Their point of view is they bounce against something. They bounce against a wall, for example, the wall, right? When they bounce, they feel the force. They feel the force. So the force that they feel bouncing around, so to speak, you average them, and then that will give you the pressure that we feel. Again, it's individual particle bouncing around.
Sorry, I think I'm lagging.
Sorry, Rio?
Yeah, I think you are lagging. Hello?
Right, okay, can you hear me?
Yeah.
Right.
Yeah, you stop at like bouncing around.
Right, the forces feeling when they bounce around. So it goes like this. The harder you hit, the more force you experience when bouncing around, right?
Yeah.
So again, it depends on the speed. The speed is higher, it bounces harder. Also, the speed is higher, it bounces more often. That matters a lot, actually. It's like you're being punched once or you're being punched a lot of times. It matters a lot, right? Once and a lot is a very different thing. So the speed gives you higher force when you kena punch and also gives you more punches. Both of that increases the pressure. That's the gase's point of view. Again, we'll go back to speed and frequency of bounce. Make sense?
Yeah, okay.
The volume is the easiest thing. I think they perceive volume, the gas perceive volume similarly to us. To us, volume is where the gas exists. For the gases itself, the volume is more like the space between them. That's the volume, the space between them. Okay, so I think volume is the easiest one to perceive from their point of view. Ken?
Okay.
Okay. So now look at B. B explain how pressure of the trap air changes. I am going to move immediately to their point of view. What is the point of view of gases in terms of pressure, which is our point of view? What is the point of view of gas?
The speed affects the how much,
right? And the frequency.
Like how hard and frequent, yeah.
Right. So we talk about the speed and the frequency of bounce. Simple. So we're going to do that. So the pressure of the trap air changes as the volume decreases. Now, if the volume decreases, the space between them decreases, correct?
Yeah.
Correct. The speed in this situation does not seem to change because speed is affected by temperature. Let's just pretend that their temperature don't change. So the speed don't change. Okay. But the frequency certainly change because the space decreases, so you have more bounces, the frequency increases.
Yeah.
Okay. So the pressure increases. The pressure increases because though the temperature of the trap air remains constant, therefore their speed, but because the space, becomes smaller, then the frequency becomes more, more bounces, and therefore you have an increase in pressure. That's basically your 3 marks. Tara.
Okay.
Okay. Now,
okay.
Are you in need of something thorough, or it makes sense to you?
I'm just worried about the phrasing, like if it's like informal phrasing. I know how to explain.
The phrasing is this. The phrasing is this. You need to use all that. Now, look, when the pressure increases, sure, but you never explain. So what you explain, this is because the air is compressed. There are more collisions between the air molecule and the what? And the
weaker at higher speed.
The higher speed is definitely not real. You're wrong, real, because the temperature affects the speed. The temperature does not change, assuming. That's why, first of all, you're wrong. The more collision, definitely correct. You just have to, when it's compressed, maybe you just add the phrasing, the space becomes smaller, so they will collide more with the thing. So maybe just mention that. Right? Actually, that's it. When you mention higher speed, you're gone at this point. You could have probably gotten 3 minutes. You're quite close.
Oh, no. Okay.
Right? And now you know why, because temperature is speed, speed is temperature. Okay?
Yeah.
Okay?
Yeah.
Do we need to talk about C and D?
D? D, C, I think I'm okay. I think.
Let me think about it for a while. This density means the 20 meter or something else. Let me think about it for a while. Okay? Right? Now, Mike, you have the drawing, right? So the only thing I will change is this thing. So how does the x over 2 affect? So I'm going to change it to half x. Okay? I'm just going to focus on this guy. Okay?
Yeah.
So if you understand this, it will be very easy for you. What is the difference between cosine x, cosine 2x, and cosine half x? The difference is very simple. If this is 360 and this is your cosine x, right? That's your cosine x. Okay?
Yeah.
Cosine 2x is very simple. Cosine 2x is you have 2. There, that's cosine 2x. You have 2 inside what is normally 1. Okay?
Oh.
And then
half,
then you have half. So which is something like this one. Something like that. Something like that's a half. Make sense?
Oh.
So let me tell you how to handle it very easily. Let me tell you. This is originally 360 degree. Understand?
Yeah.
And you will now do this. You will now over half equals to 720 degree. Right? Notice what happened here. This 180 degree, right? Over half. It will become 360 degree. The half comes from this. Okay, so far so good?
Yeah.
I have successfully made 360 only half long. Okay, understand? Instead of changing the shape, drawing a different one, you change the scale. I think that's easier. That's the same thing that we did with the y-axis. We understand, Mike?
Yeah, so if you half it, it becomes 720.
Divide by half. I didn't halve it. I divide by half. I divide by half. It becomes 720.
Okay.
Effectively drawing the same thing. See? 360. See? 360.
Okay.
Understand?
Yeah.
So whenever later you encounter this 2x, 3x, 360 divided by 2, 180. 360 divided by 3, 120. That's how you handle the number in front of x. You change the scale. Okay?
Okay. Yeah.
Right. Noah, any questions?
Yeah.
Okay.
Yes, same one.
So you found the gradient, right? Yeah, the gradient seems to be correct. Now you don't know how to find C, right? So when you find C, don't go to 1 over y first. That's my mistake. I asked you to do it too early. So change the 1 over y to big Y, change the x squared into big X. Please change it, right? That's my mistake. Sorry, I asked you to do it now. This is now very easy to find C, because you can use the big X and the big Y. You can use either 1,2 or you can use the other coordinate. And you plug it to big Y and big X, you will find the C. Make sense? That's just normal correct geometry.
Yeah.
Okay, and then you go back to the original one, right? Aryan, do you have a new question so far? Because I'm not seeing. Sorry?
Just like that or what?
I cannot see what you're doing.
Oh, just sub in. Oh.
Yeah. Put 1,2, for example. Make sense?
Okay.
Let me see how you do it. Right. Hands up, please. Hands up, please. Very good. Yeah, then you find the C, and then you just plug in on top, and then you can do what they want you to do. Aryan, do you have a new question?
Yeah. I kind of forgot about latent heat.
Okay, not difficult. Yes, what is it?
Like I'm not sure about the formula.
The formula is actually simpler. Right? The formula is actually simpler. If you think about forgetting formula, don't worry. At page 2, latent heat of what?
Latent heat of vaporization.
Let's say vaporization, right? Equals to, right? No. The Q needed to evaporate is equal to latent heat of vaporization times the mass that you're vaporizing.
Oh, so it's
Compare that with Q MC delta T. MC delta T, right? This is even simpler than that, isn't it? They are simpler.
Yeah.
Because during vaporization or some other changes, you do not have delta T. There is no change in temperature. It is really as simple as that.
Oh.
Right? Does that answer your question?
Yeah.
Right. If you cannot use it, you tell me. Ryotaro, any question?
I'm looking at part C. Yeah, I don't know what they mean.
Okay. You mean the pressure? Sorry. Part C means the pressure.
No, the density.
Oh, the density.
Yeah.
That's part D, right? Part C or part D? Sorry.
No, like there's a circle and then they said fluid density. Like they circle my M over V.
I'm checking. Yeah.
But I didn't know what to put for the density. That M over V. So I just put M over V.
Right. Now, first thing first. Did they say something like this during your studying of this? Gas is compressible. That means gas can, increase or decrease its pressure, increase or decrease its volume, right?
Yeah.
That's just our experience, that's understandable. Liquid, or they call it fluid, fluid cannot be compressed. You cannot compress a bottle of water. As in, you cannot decrease its volume. It's extremely difficult to do that. So basically, for everyday purposes, you cannot change the volume of water by simply pressing it. It will never work. Okay?
Yeah.
Did they tell you that?
Yeah, I think so.
So basically, when you think about the density of water here, I know it's ocean water, so it's a bit denser lah. It's a bit denser than normal water, but that's not because of the pressure. It's because of the salt dissolve. Okay, it's because of that.
Yeah.
So normally, sometimes you even assume the density of ocean to be 1 because that's just the same as normal water. But there are some differences lah. So a bit heavier lah, a bit heavier. That's why you float more easily in ocean, which is salt water. Okay, so far so good. So the density here is probably referring to a number or something which is slightly more than the normal water density, but not because of the pressure. It's because of the salt dissolve. So far so good. Probably that doesn't answer how to do it, but that's the meaning. Okay, so far.
Yeah.
Okay, so at this point, yeah.
What is amplitude?
What is what? Sorry.
Amplitude.
The amplitude. Sorry, amplitude. Oh, amplitude is from the middle point to the topmost point.
Oh, then what is the period?
Period is 1 cycle. 1 cycle. 1 cycle. How long? So, for example, the normal sine graph is 360.
So 720 degrees.
Excellent.
Then,
excellent.
What is the maximum value of the curve? Is it like
the maximum point in the middle? Exactly the highest and lowest point, which you can see from your drawing.
Oh, okay.
Right. It's that those things are quite visual. I hope you always see it that way. I don't memorize it. Okay. Right.
Yeah.
Okay. So Ryotaro, what it goes like this. So you know the pressure during the 20 meter. You can actually calculate it from the volume of gas. So here's my question. Can you calculate the pressure from the volume of gas? So you don't use your PAPM and rho PG. Actually, you use it in part D. On part C, you can calculate it like, for example, at height 0 meter, basically on the surface, your volume is 30, right? At height 20 meter, your volume decreases. That decrease in volume almost immediately tells you about the increase in pressure. It's almost immediately one, but not through your normal rho PG, rho GH and P atmosphere, not through that normal thing. Like you're supposed to, I'm not sure whether you're supposed to know this or not, but PV at P equals to PV. So at 0 meter, at 20 meter. Have you seen this before?
Yeah, maybe.
All right, so then I'll do this. So the P1 is 1 atmosphere, right? Because that's at 0 meter. You know this and you know that, okay? So P2 will be P1 V1 over V2, right? Which is to say your P1 is 1 atmosphere, right? Your V1 is 30 centimeter cube, and your this one is 9.4 centimeter cube, if I'm not mistaken. Okay.
Yeah.
So this one you get something like almost 3 ATM. Like you can just press the calculator, and this is almost 3 ATM. Okay. You're gonna use this 3 ATM, put it here, 3 ATM, this, that, and then this is your part D. So you answer basically your part C and your part D. This is...
Wait, sorry, 3 ATM is what?
The pressure at 20 meter using the volume information.
Okay, 3 ATM.
Right. So your 3 ATM will go back here. 3 ATM is now equivalent to pressure atmosphere plus rho GH. But that's part D. You will get your ocean water density that way. Basically, your part C is totally wrong. Basically, that's why you don't get anything. That's supposed to be for part D.
Then part C, what am I supposed to do?
This. Totally different thing. This. Okay.
Okay.
Totally different thing because you cannot do this here and expect an answer. Your problem is this. That's why you cannot use it. You don't have the rule.
Okay.
Okay. Normally you have so this time you can. Okay. Think about it.
Yeah.
Aryan, do you have another question?
No.
All right. Soon enough, we'll answer your what I owe you 2 questions. Huh? So Noah, any questions so far? Noah, any questions?
Can I do the question like this?
I see that you do that. So this is a different question, right? Do you have problem with one just now, or are you done with that? Okay, let me see first. Let me see. Let me see your C. Your C looks, I suppose, about. Wait, I'm a bit concerned with your C. Let me think for a while. Let me just think for a while. Yeah, your C cannot be -1. That doesn't make sense at all. Whoa, you did a very simple algebra mistake. Your C is not. Your C is yeah. Whoa. That mistake is not okay. Yeah, that's not okay. Giving you a bit of pressure. That mistake is not okay. Yeah. So the C is +1. Okay. So now the way you do it on top is great. Now, the only problem is this. You should not stop there. You're going great because he wants you to express y in terms of x. What does that mean? He wants y as the subject. Okay. So like basically make y the subject. You are not there yet, but you are on the right track. Do you understand?
Yeah.
Okay, good. Mike, any questions?
Any questions so far? No, I don't think so.
Any new question? All right. Ryotaro, any new questions?
I'm still looking at the question you were explaining just now.
All right. Now, what will happen is this, like this 1 hour, right? This week we are testing so that 1 hour we stick to the point. So soon enough, Mike and Noah will leave. I'll explain the Aryan's question and then I'll get back to you. Would that be okay?
Yeah.
All right. Okay. So Mike and Noah, ask your last questions. If not, let's just stick to the timing first and then we'll stop the tuition at this point. You should continue at your own studies, right? Any last question, Michael? Any last question, Michael?
Can I just do like one more trig, I guess?
Okay, but last question, as in last thing to ask. So Noah, any last question from you? Right? So I'm looking at what you're doing. What you're doing seems very reasonable to me. Your y/mx plus c is great. The way you find m makes a lot of sense. It looks like a -½ gradient to me. The way you find c, can I see? Can I see your c? The c seems to be 3, right? So, there's another mistake there. Yeah. Can we see the graph? Can I see the graph? Can I see the graph? 3 looks about right, no? I guess it looks about right, right? So find the value of A and B. So your A is not 3, you're wrong. 3 is log A.
Oh, okay.
M is B. That is correct lah. Your B is your M. I like it. But your C is your log A. So you're a bit mistaken there only. Make sense? Right? Yeah. At this point, I will see you on 2 days from now. Okay?
How to get rid of the log?
Ayo, use your logarithm skill lah. Log A equals to 3. Then what? You do not know how to do it? No way. This is your basic logarithm. Tell me you know. You don't know?
Is it the logarithm to exponential?
Yeah, so I'm just going to run down for you because we are running out of time. So look at page 1. So currently LGA equals to 3, right? Currently lah. Yeah. You know that LG is log base 10, right? So I'm just going to make it very clear lah. Log base 10, okay. Correct? Okay. So then you 10. You understand? 10 to the power of that. So this one become A log A is like that. No? You're supposed to do that. You just okay. And very good. And I'll see you 2 days from now.
Okay, see you guys.
All right. Michael, any last question? If not, I'll see you 2 days from now.
Just question 10, but A part only. That's it. I just need to actually understand.
When you say question 10, what do you mean by question 10? Sorry, question 10 is?
Question 10 is this one, but just A part.
Okay, let's go quickly. Yeah, you know A is like, for example, the 2 cosine x. You know that, right?
Yeah.
Okay, and then you know B is the guy in front of x, right? The guy in front of x affects the period. That's what you learned just now. Correct? Basically, if the period is 180, you can immediately predict B is 2, man.
So right now, so it has amplitude of 2.
Basically, you write something like this. 180, when you write it, 180 is 360 divided by 2. You write that down, please. I'm going to tell you how to present. Write down 180 is 360 divided by 2, isn't it?
Yeah.
Isn't it? So 2 is the B. Make sense?
Oh, okay.
Is that? We're just basing it on
2 is the B.
Yeah, because 2x,
2 is the B.
cosine 2x, right? Cosine 2x means you have two graphs
Yeah.
inside 360, ma? Correct or not?
Yeah.
So the period of that graph
Yeah, okay.
must be 360 divided by 2. So you solve the B already. Can?
Okay.
Now the amplitude is 2. That's also the answer for A, because A basically just, 2 cosine x, you just 2 times from 1 to -1. So become 2 to -2. A is 2 because the amplitude is 2. If that makes
Then
sense.
how do you know? But then, okay, amplitude is 2. Okay, but then what about the minus C? And how?
Good. So the minimum value is -5, right? So you look at your Jamboard again. I'm basing it on the skill that you learned just now. Huh? Look. Again, by right, this should be 1, 0, -1, right? By right lah. Then 2, 0, -2, right? Right. And then suddenly this -2 is -5. Suddenly, that's what he's saying. C is -3, look. So simple one. So simple. Make sense?
Yeah.
Remember, that's how we deal with 2. 2, 0, -2. How do you deal with 1? 3, 1, -1, right? So now to draw it, this is -2 to -5. What happened to 0?
0. What happened to 0?
You don't get what C does. Huh? What does C do? What does 1 do? 1 changes 2 to 3. Changes 0 to 1. Changes -2 to -1.
0
right?
becomes -3.
Good. And 2 becomes?
2 becomes -1.
Right. So what is this? -1. What is this? -3. What is this? -5, right?
Yeah.
Where is your x-axis? Here, lo, right? There. Who is this guy? 180, lo. Done, lo.
Oh.
Makes sense. We are using the same skill set. I just answered the C for you.
Oh.
Okay. You think about it. Okay. You think about it. This is very important skill set. Okay.
Okay.
See you in 2 days from now. Don't forget.
Yeah.
Okay. Right. Bye. So Aryan, I can now answer your question. Ryotaro, please quit. Right. So first thing first, I will answer the. Now Aryan, you don't happen to have any slinky with you? Any, you know what's a slinky? Sorry.
Oh, no.
No, yeah. Right. Okay. So I will have to answer your question this way, lah. Right. I draw something on page 3. Can you see it? Right. So I shake my slinky like that, up and down, up and down, up and down. Can?
Yeah.
Let's call this position A. And let's call this position C. And now I'm going to call this position B. This A and B represents the 2 points that the question is asking. So far, so good?
Yeah.
Right. Now, do you understand? This drawing is a very bad representation of the moving slinky. The slinky is moving. It's not stationary like this. Can you accept that?
Yeah.
So tell me, because the slinky is moving, what is actually happening with A? Please tell me that.
It's moving to the right.
No, up and down, up and down. So downward. Right. So the A should have been moving up and down, but because my drawing is not a video, a drawing is unfortunately not a video, I cannot capture the moving up and down. If only this paper is a video, then it will be better. Again, make sense?
Yeah.
Now, what I want you to notice is, out of this limitation, we can still think like this. The movement of A and C is exactly the same. When A goes down, C goes down. When A goes up, C goes up. They are exactly the same. So does point D. The movement of point D, point C, and point A will always be the same. When they go down, they go down. When they go up, they go up. Can you at least imagine that?
Yeah.
However, the movement of point B, even though it's also moving up and down, I understand. the movement of point B is not exactly the same as A and C. Not exactly. Can you accept that?
Yeah.
Okay, so I'm going to just make it very clearly. Yeah, I'm going to make it very clearly. Yeah, just by drawing this. So let's say the black is T at 0, and let's say I'm going to draw a blue one. The blue one goes like this lah. Sorry. So the blue one is when the wave moves. Remember, the point does not move, but the wave moves, right? The wave does move to the right. Okay, Ken?
Yeah.
So A does go down after a while, after 0.1. So A does go down, C does go down, D does go down, B also in this case goes down. Can you?
Yeah.
However, there'll be a moment where when A goes down, B will go up. If you just find the moment. So I'm doing this very fast. Again, this makes sense?
Yeah.
Now, show me the question more clearly because I cannot see the right part. Just move to the left a bit. Okay, then move up. I need to see the graph. Move up. Okay, thank you. Okay, I'll stop there. Right. So your A and B is like that. Now, when you see the graph A and B, now you think carefully. Yeah? Your A and B relationship is like A and B, or it's like A and C. Do you understand my question?
Oh, yeah.
Okay. What do you think their relationship is like?
I think it's like A and B.
Which is not A and C perfectly in sync. Let's just call it they are perfectly in sync. They are not in sync, is what you're saying.
Yeah.
In fact, I think I'll invent a new point. In fact, I think looking at the graph, I think it is at point E. I think A and E is our relationship here. Do you know why I suspect it that way?
Because they are opposite.
Wait a minute. Wait. This is very weird. Wait. Let me think about. Oh no, it's okay. It's okay. Oh no. I made a mistake. It's not A and E. No. My mistake. Huh? No, my mistake. I'm gonna just do it for you. Huh? So first of all, I will now do a new point A. I believe this is a better point A than this one. Do you know why?
Because that's where it starts.
Well, when I see your A, I see that it starts from displacement 0. That's why I see.
Yeah.
So I better put A here instead of here. If I put it here, the displacement is not 0, it's actually maximum. It's very confusing for me. Make sense?
Yeah.
So that's my new point. You will agree. Now I will now try to find the point B. Now you're gonna use your Jamboard for the first time today. Just use a mouse and tell me what is the likely point B. Is it here, 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 here? You know, what is the likely possible points for B?
Like a bit below the line.
Are you sure it's a bit below the line? Because I think it is below the line. But are you sure it's a bit below the line? Are you sure it's a bit below the line?
Yeah.
At point 0, what's the vertical displacement of B?
Wait, point B or graph B?
Look at graph B. At times equal to 0, what's the displacement?
It's negative 1.5.
Which happens to be the maximum displacement. Are you sure it's a little bit below? Are you sure it's only a little bit below the line? Are you sure?
B here.
Yeah, I think that's a likely candidate. By the way, this is also possible. You understand? This is possible. This is also possible. So every point like this is possible to be B. Does this make sense to you?
Yeah.
Right. However, I need to state that this is also possible as A, you know. It is also possible. It is actually possible. So A have some possibility and B have some possibility, but they are kind of fixed in that way. So we are reading the graph and determining this is A, and this is B, 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 B. So far, so good.
Yeah.
Okay, now we answer the question. Your question is, I think part C or part B, right? So let's go.
Part C.
Okay. So point B is 38 centimeter to the right of my wave. See, there are several possible values of speed of the wave on the road. The reason is simple. The reason is simple. So I'm going to explain. By the way, this thing is definitely not level 1. This thing is already like level 3 something. So maybe this is 38 centimeter. Maybe this is 38 centimeter. Maybe this is 38 centimeter. It does matter which one, but currently we don't know. Understand?
Yeah.
Okay, now I'm going to just show you. I'm just going to show you. So I'm going to explore possibility number 1. Therefore, 38 centimeter is 1/4 of lambda. Does that make sense? Is 1/4 of the wavelength. Make sense?
Yeah.
Whereas in second option, 38 centimeter is 3/4 of lambda. Make sense?
Yeah.
Let's say the third option, there are many options. So 38 centimeter is how many lambda I have to count? 1 3/4. So 3 is 1 3/4 lambda. Make sense?
Yeah.
So in the first option, tell me what's lambda. The second option, tell me what's lambda. And the third option, tell me what's lambda. Okay. Do you know how to do that?
You find the wavelength.
Yep. You find the wavelength first because 38 centimeter is 1/4 lambda. The lambda is use your calculator.
Sorry, it's 38 divided by 4.
Come on. This is basic algebra, yeah. Basic algebra. No, Aryan, I'm not asking you to guess. I'm asking you to do it properly. So,
152.
152 sounds about right. The second one.
Second one
is an uglier number, 50, I think.
50.6.
50.6, yeah, 50.6 dot. And the third one will be shorter. So the third one will be, this is 7/4 lambda. So, what is it?
21.7.
21.7 dot centimeter, right? Okay, so one of these will give you the 200 centimeter S, right? So you know V is F lambda, right? You know that, right?
Yeah.
I believe the first one will give you your answer, correct?
Yeah.
Okay, check us. I think it's around 203 something, right?
Oh, yeah.
Okay, so currently you already work on part 1, Ken?
Yeah.
Part 2, you can immediately answer based on this drawing.
Oh.
Make sense? We already covered part 1 and part 2. This is advanced. This is not basic. This is making you understand wave very much, which is I like. That's why I like your question and I want to take time to explain it. I believe your explanation should involve the drawing. There is no better way. It should start from the drawing. Understand?
Yeah.
So draw and then do the options and then you can already explain the possible values. Spend time here. This is very good for your understanding. Ken?
Yeah.
Okay. I want to answer your second question now, which is the one just now. Can you?
No, I was just asking for the formula, the later.
Oh no, I'm referring to the brass cup and all that.
Sorry,
the brass heat capacity. I still haven't answered it.
Oh yeah, that's one.
Right. Okay. Okay. I'll answer that and then we'll stop tuition for today. I'll see you 2 days from now. Okay.
Yeah, sure.
Okay. Right. So yeah. After thinking about it, right, I'll write down with no heat loss. So there's a little bit of heat loss, right? A little bit from the top here, right? A little bit of heat loss. A little bit.
You've already answered the question, I think.
Sorry, you're saying?
I think you've already answered the question.
I have not. What do you mean by that? Sorry, what do you mean?
No, I think you've already told me about the heat loss for the surroundings.
Correct, but I haven't answered the final. The final question is whether the whether the actual value is higher or lower. So I have to arrive at that part. Okay?
Yeah.
So I will start by, if there is no heat loss, what will happen? If there is none, then I believe 45 degree will be higher because there is no heat loss. Right? So then this is weird. Let me think about it. It's very weird. Wait, let me think for a while. This is very weird. Wow, this is very weird, isn't it? Wait. Wait, this is very weird. Okay, I'm not confident to answer right now, Aryan. I'll do some calculation just to make sure that I'm correct. Sorry, this part I'm a bit confused again. Seems to be different from what I'm thinking. Okay, I'll send you the final answer later. Can I do it?
Sure.
Okay. Now, Aryan, before you go, again, is there any technical problem today?
No, nothing.
Seems good, yeah? All right. Yeah. I also enjoy your video. It's very smooth. I like it a lot. Now, is there any other problem that you noticed? This is your second time, right? Doing this new thing. Anything? Any other problem?
I don't think there's a problem.
Okay, then we'll try the same thing on Thursday, right? Thursday night. And then let's make a conclusion whether it's a good thing. Okay?
Sure, yeah.
Okay. I'll send you the answer later. See you.
Sure.
Right.
Bye.
Bye-bye. Okay, so Ryotar, right? Are you there, Ryotar?
Yeah.
Okay. Ask me any question you want.
Oh, wait, just now that question, is it the answer for C is just 3 ATM, just like that?
I think higher than 3 ATM. I think higher. So you have to use the calculator. Just slightly higher.
But how would we? So
press the calculator. 30 over 9.4 first thing first, and then I notice you're not supposed to use ATM, you're supposed to use PA lah. So times 1.01 lah. Right? So use your calculator. Right? It's not supposed to be 1 ATM, but 1.01 times 5 PA. Same thing as 1 ATM lah. So we'll use that lah. Okay, so calculator 30 over 9.4 times 1.01 is
1.01 is the what?
Wait a minute. Let me check this thing. The pressure at 0.1, which is at here. The pressure here is 1.01 times 10 to the power 5 PA. Would that be okay? The pressure here.
Yeah.
Right. So that's why we have 1.01 times 10 to the power 5 lah. Okay. That's P1. No?
Oh, not just 1.0. Yeah.
No. Yeah, of course. Right. Okay. And then your V1 is 30, the V2 is blah, blah. So your answer at this point should be like more than 3. What's the answer? Pressing the calculator.
you strip on something, but now I'm doing the 1.01 times.
Yeah, which
It
is
was
3. Yeah, so if you could have not included a 10 to the power of 5, right? You could have answered it as 3.22 times 10 to the power of 5. I think that's an easier way to do it. You don't need to include the 10 to the power of 5. The reason why standard form exists, is standard form, because you don't have to include them. It's much easier, right? See, the answer is the answer. You cannot use the answer. That's why you don't use the AC everything. Reset. You have a problem. You have a problem with your calculator. Now press the fraction.
okay.
Press the fraction and then do 30 over 9.4, right?
Oh.
Right. Do 30 over 9.4 and just times 1.01. That's what you need to do in your calculator. I believe, yeah, then you press RC, 3.22 times 10 to the power of 5. The 10 to the power of 5 should be left out. It should be. Understand?
Oh, okay.
It should be. That's why it is there, to be left out and then to be inserted back. Simple stuff.
Yeah.
Okay. That's pressure tool. That's your answer to part C. 3 marks looks like a lot. Yeah, but the understanding is also a lot. Physics, it always has a short answer, but a lot of understanding. But okay.
Oh, then the part D is just that thing divided by.
No, equals to this. Equals to this, right? So you must this minus that first, and then divided by, I think, the H and the G .
Oh, sorry, what minus what? I
Okay.
couldn't see.
Yeah. Just going to write down here, right? I'm going to use a different color, which is, again, I suppose blue, right? So 3.22, right, times 10 to the power of 5, right, equals to this thing, right? 1.01 times 10 to the power of 5 plus rho GH, right, which is again 20. G is 10, and then times the rho . Okay, so this.
Oh, you must minus 200 then divided by.
No, minus this. No.
Oh, wait, no.
This minus that, right? This minus that divided by 200.
Okay. Yeah.
That would be your rho.
Okay.
I suppose. Well, voila. That's it. Just press the calculator and tell me what is the answer, so I can have a feel whether your answer is correct or not. Should be should be as in 1,000 plus a bit . As promised, ocean water is slightly denser than normal water.
$1,105.
1,100, I suppose. Yeah, I mean, it's a bit more than 1,000, no? Something like that. Okay, so now Google density of ocean water.
Okay.
Just check so that you know whether you're right or not. Yeah, about there. Yeah, about there. Should be
1,026.
Yeah, your number is a bit higher, but that's what we get. I don't see any problem with your working. That's what we get.
Okay.
Yeah. So yeah, we'll deal with that. Okay. This covers this one question covers a lot of the topic. If it doesn't confuse you, good. If you're trying to memorize the method, you will probably fail to apply it in the exam question, because the next question will not be exactly the same as it. You need to understand the reason behind it. Okay, that's why I firstly object discussing so long, because you may memorize it instead of understand it. That's bad. That's very bad. Are you sure you understand?
I think so.
Okay, fair enough. I mean, I trust your physics. I trust you. If you want to finish another question, maybe just one more, just to make you happy.
Actually, I'm like quite. Even after the test paper, I was already tired. Like
I'm
in the
not surprised.
afternoon.
I'm not surprised. I'm not surprised. We should stop
I don't
studying
think
at
I
this
can
point. Good.
think.
Stop studying at this point.
Yeah.
Now, I want to settle a technical problem first before talking more. So actually, I want you to stop the Zoom and then remember the. Oh, no. You no, never mind. I just remember you said something. No, never mind. We'll settle it next time. Sorry.
Oh,
Now,
okay.
let's just talk about your math a bit and how are you feeling?
You know, the teacher said the math paper will be easier as compared to SAT. That was a lie.
That was a lie, right?
Yeah, the only difference is like 50 marks instead of 90.
So
That's
he's
like the
lying to
only
you
easier.
and other students that's taking the test.
Yeah, all the students like look depressed after the paper.
I wouldn't be surprised, right? I wouldn't be surprised, you know. We are either lucky or blessed that we practice at the end of year level, right? That we did.
Yeah.
Because I mentioned it's actually very difficult to guess how easy it will be. It was very difficult and we shouldn't do it. So it turns out that was a good thing. I'm curious how they managed the 50 marks. How did they reduce 90 marks to 50 marks? Like what? They take out topics or what?
Yeah. Some like, for example, binomial, they like only put one part, like find the coefficient of x squared in the expansion, blah, blah, blah.
Right.
Yeah, instead of like 3 parts. Or like there was, I don't think there was a single circle question.
Right. Which we basically did not eliminate any topic. Like we end up covering most of it, right?
Yeah, but some I felt maybe a bit trickier than last time. The SA2.
Right. So if we have if you have rolled the dice and you know, let's assume certain topics will not come, certain topics we would have come now also.
Yeah,
but we did not. So I would thank God. I'm very happy to hear that you miss all the dangerous stuff, all the wrong assumptions.
Yeah. Those circles and binomial, at least it's not like majority of the paper. It's like very little.
Correct. So what you practiced came as in, I suppose it was useful, I suppose.
Yeah, but the paper a bit tight because there are some parts like the topic I practice, maybe I can go like almost until the end, then a bit confused. So I like try to do the next question first.
Yeah. So you basically just cut out the confusing part, which is always what you need to do.
Yeah.
Because you are still slow. Slow doesn't mean bad, but that's the decision you need to take. It's the right thing to do, really.
Yeah.
It's the right thing to do. What else? How do you feel?
Because some of the question I thought my answer weird, so I just continue first. But actually, after the exam, I asked my friend, then they get the same answer.
So that means you did not confirm lah. That's
I confirmed some only because some I really like super long question. I can't confirm everything.
Right. We'll manage the time later. Don't worry.
Yeah.
So in summary, how do you feel besides feeling tired?
I'm quite relieved. Like I practice some of the questions I practice, like similar things come out, so I'm happy. I'm quite happy. But I'm a bit sad, like some parts maybe a bit like careless now that I think about it. I probably like maybe one question that I practice maybe out of 5, because small careless maybe like 3 or 4 marks.
Okay.
Yeah, but like maybe answer a bit wrong, but the method is correct. So I still get marks. Yeah, that's like most of the question. But then the linear law and linear law, I just try my luck because I never really practice. Yeah, but I think I can pass. A, I don't think so though. Because
pass and A very different. Pass and A very different.
Maybe like a B, I would say. I think
you don't
I don't know.
Like it's either you lose or you win, you know. That's how you think about things sometimes, right? Either I pass or I get A. Like what?
I think it's safe to say B. B to low A.
Right.
Yeah.
So
but okay, I think pass, at least pass. Yeah.
Seldom hear you optimistic, yeah. So as you say, we shouldn't, you know, celebrate early, right? All right. So I'll just
no, I don't want to jinx. Yeah. Okay.
I'll just say something nice. I'll just say something nice. If you indeed pass, see, not jinxing anything, eh? If you indeed pass, you have erased you have replaced the negative experience of your end of year completely because the difficulty level. If the difficult level were to be easier according to the promise, it will be good for most people, you know. It will be good. It'll also be good for you, of course, but it won't be as good as what we are thinking right now. Again, not using it. If you do pass this time, your end of year has been surpassed. And you no longer need to, I suppose, carry the burden, I suppose. You have growth, you have grown, basically. You have grown if you pass.
Yeah, if I pass.
So until we pass, then we talk about it. But I think you will know the result very soon, right? It's only a few percent.
Oh no, it's actually quite a lot. It's like they have to separate two whole classes, two whole classroom for the number of people.
There is a lot of people who fail last time.
AMF, actually there's even more who fail physics and chemistry. AMF is the 4th worst paper. So the worst is social studies. Like only 3 people pass. In my whole class, only 3 people pass.
Your SS fail of us. Your SS fail of us.
Yeah, I fail.
Oh, you're supposed to be good at language and humanities. What nonsense is that?
Yeah, I don't know what happened. Like, and those people who pass is like the 6-point people. Like they barely pass.
Right. I wouldn't complain, of course. I'm just joking. Yeah, just pulling your leg. Right.
Yeah, it was like quite a horrible experience.
Yeah, it was. It was. It must be like. Now, never mind. We shall talk about it when you know the result. But you have told your dad, right?
About the AMF?
Yeah.
Yeah. I told my mom that.
You told them, right? Okay, right. Okay. So now for physics, which is like when I see you next time, like on Thursday, like physics is done, right? Am I correct?
Yeah, physics Thursday. The test.
So you have tomorrow to prepare, and then
tomorrow.
Yeah, but you shall not put yourself in any form of pressure. You shall do what is correct, which is, for example, you should stop right now. We're just talking right now. We're not studying. You should be stopping right now because you have to recover some mental reservoir. Like doing an exam is draining. Everybody knows. Right? So we're just talking about it. I'm just hoping that it will make you relax better. This is just, before your sleep, that kind of thing. Right? That's why we're talking. That's why. I'm not here to evaluate you or, You did well. You don't. No, that's not my point, right? It's not my point, right? We're just talking about it, right?
Yeah.
Same way tomorrow. Don't put additional pressure to yourself simply because there's only one day left, and obviously you didn't prepare for physics too much. Don't do that.
Yeah.
Don't do that. That's obvious, but first of all, one more time, the stake is not as high. One more time, just to be very clear. Okay?
Yeah.
I'm not saying that you can therefore do bad, but you also won't do that. You're not that kind of person. You're just afraid you will do that. Whether you do bad or good this time, your experience probably won't be as good as the math one. Obviously lah, right?
Yeah.
Obviously. So I really say the only thing you can do is study at your prime time and then sleep low. Really, because your physics is not that bad. It's just that you're not at a level you want to be. Like when I see your physics, oh yeah. I mean, you did some mistake. The mistakes are silly, but the basics are there. Sometimes I don't get the same feeling with AMAT.
Okay.
You know a lot of things about AMAT, but I don't know how to describe. You're like a ocean in a storm, like there's a lot of things there. Boom, bam, boom, bam, boom. You're not an empty vessel, but your physics is much calmer compared to your AMAT. Like as per usual, you know your things, but you're more synchronized or you're more connected in physics. That's what I feel. Again, you won't do as
the concept. I understand.
Correct. We just have to, sharpen it, make it better, go forward together. But we haven't devoted the time. That's fine. It's fine. Please don't expect that the experience will be as good as math. Don't lah.
Yeah.
Just do your best, and maybe you'll surprise yourself. Maybe you won't. That's fine, right? It's fine. It's really fine. After physics, we'll meet. Just relax on Thursday. Then you take a rest, and then we'll deal with Chem.
Okay.
Right? Physics, not lower your expectation, but more precisely, have no expectation. Just do your best. I think that's the best way to say it.
Yeah. Okay.
You will probably be fine if you have no expectation, therefore no pressure, therefore you can do your best. I think they'll be fine. Okay. Yeah. So anything else before we sleep lah?
No, I don't think so.
Right. So just tell me a little bit of your friend. What's going on here?
You mean the depressed ones? Like the one who...
Oh, okay. Now I know he's depressed. So why is he depressed?
No, like after the math paper, like most of the people look very disappointed from my class.
The friend that you mentioned want to take tuition, blah blah blah, is also very depressed.
Yeah. Not just him. Yeah, like those from my class taking the paper. Like I didn't see any happy people.
Right. I wouldn't.
Most. Most of the people I asked is like I confirm fail already, or like if I just pass, it's a miracle or something like that.
Right.
Yeah.
I wouldn't be surprised. I wouldn't be surprised. They might be lazy, they might not, but it's just difficult to prepare by our own. It's just difficult for AMAT. It's plus the difficulties, I think. Crazy. I don't know what will happen. I don't know. Okay. Don't be happy because you're better than them. Don't be happy. Don't be happy.
Yeah, I'm not happy at all.
Be happy because you probably did grow. We'll see. But you probably did grow. Be happy because of that.
Okay.
Okay. I'll see you when I see you on Thursday. Bye, Retan.
Okay. Bye-bye. Good night.